One of the things that comes up a lot, especially if you start looking ahead towards the AP exam, is the fact that we can actually bring the idea that differentiability is going to imply continuity. We can kind of bring that to the table and work it back into problems involving the intermediate value theorem. So let's pose a question here, and this is actually something that comes up very frequently when you look at the AP exam. Let's say that we have the differentiable function g of x with select table values. So let's say that we have a function, we're told that it's differentiable, meaning that the derivative exists at every single point in g of x, and we have these values. So we'll have values for x and values for g of x. And the values we're going to have are going to be 1, -3, 2, -1, 3, 4, 4, 3, 5, 1, and 6, -4. So that's what we've got right now. And what we're going to be told to show is show that there is a value, c, on the interval 0 to 6, where we have the table values, such that g of c is equal to 0. So here we are. This is a problem, and this is exactly how it could be worded on the AP exam, and it's something that we understand now. The fact that we're given a table of values, we're told the function's differentiable, and we want to show on this interval that there's some value where g of x equals to 0. And so we're going to use the intermediate value theorem. The intermediate value theorem says that if a function's continuous, and that for this particular function, if I can find an interval where 0 is in between two function values, then I'm going to be able to say by the IVT that there's a c that g of c equals 0. But the intermediate value theorem implies or relies on continuity. We're not told anything about the continuity of this function. We're going to have to state that g of x is continuous, and we know that because g of x is differentiable. And so it's just a matter of making that connection. So because g of x is differentiable everywhere, it is continuous everywhere. You get to make that claim. If it tells you something is differentiable, you now get to say that also means it's continuous. Please remember that if it tells you it's continuous, you don't get to claim it's differentiable. But if it tells you differentiable, then you get to make the claim that it's continuous. Now then, it's continuous everywhere, so it's going to be continuous on the interval where I can find 0. Now then, remember that if I look at values from 0 to 6, and really all I have on this table are from 1 to 6, but if I look at values right here somewhere where I'm looking that it's going to go through 0, remember I can't use these two values right here because that doesn't guarantee that it goes through 0. I have to find somewhere where it definitely captures 0, and I can see that that happens here between the function values -1 and 4, and so I'm going to use the interval 2 to 3. So because g of x is continuous everywhere, it is also, I can say therefore, g of x is continuous on the closed interval 2 to 3. So I've said my first main thing I'm going to use on the intermediate value theorem. G of x is continuous on 2 to 3. I had to get there by using the differentiability, but I got the fact that g of x is continuous on an interval. Now I can say g of 2 is equal to -1, g of 3 is equal to 4, and I can say zeros in between those values. So let's formalize our argument here and say since g of x is continuous on the closed interval 2 to 3, and because this is where I have to write that inequality statement showing that 0 is in between these two values. So g of 2 is equal to -1, which is less than or equal to 0, which is less than or equal to 4, which is what g of 3 equals. That's what I needed to say. I've said it's continuous on that interval, and 0 is in between the function values on that interval. So now I can say there exists a c on the interval 2 to 3 such that g of c is equal to 0 by the intermediate value theorem. And again, when using the IVT, you want to make sure you actually cite the IVT, and you can abbreviate it if you would like. Now then, that shows that there exists a c on the interval 2 to 3. We were asked to show on the interval 0 to 6, so I can say from here that it logically follows that there exists a c. If there's 1 on 2 to 3, that means there's 1 on 0 to 6, such that g of c is equal to 0. So you can use differentiability. Really, this was a problem straight out of 1.16, but now because I was told the function's differentiable, I can make this claim about continuity, and then I can proceed with using the intermediate value theorem.